Right, today we're going to continue section 1.5. So first we're going to fill out our ISN for it. The first topic is adjacent angles. Now, to remind you, an angle is an opening. Okay, this is this angle. And this one is another angle over here. Did you have a path? Maybe your teacher was going to give you one. Tell me where you came from, please. So, okay. Make sure you have a pass next time. Okay, adjacent angles. The way we worded it the other day, we did write that they were, in your own words, angles next to each other. And they have a common side. That would be the ray in the middle. This is the common side. They don't share any interior points, and that's what we're going to read on the next, on the right side. So I'm jumping over from here to this. So it's on the right, the top right. Are you with me where it is? We got the picture on the left, and then we have this definition. This is adjacent angles. They are two angles that lie in the same plane and have a common vertex and a common side, but no common interior points. Okay, meaning all of these points in here on this angle are separate from, I want to get a highlight, it is the highlighter, okay, from all the points in here. Okay, and likewise, I'm going to color down here on this one, this angle, and the one on top. Okay. Eraser. Don't like the messy out of the lines there. Okay. What do we want to say about these? Well, we use words that are, again, it was angles next to each other. I don't know, I think that illustrates it pretty well, just coloring it. And remember that there's the common side is the ray between them. All right, and that's applied to both angles. All right, so next we're going to do vertical angles. I got to go backwards, so we're going down on the left side, right here. Vertical angles are angles, kind of, we've said that they were across from each other, and then I had someone else say opposite each other. So I'm going to color the one at the top and the one at the bottom the same because they are the same size. And those are vertical to one another. And I'm going to color these on the left and right a different color because they're not the same size, but they are vertical to one another. And again, in our own words, what we said was they are angles across from each other. Okay, I'm going to jump over to the other page. Does anybody still need this before I move? Okay. All right, jumping on over. These are vertical angles. are two angles, are two non-adjacent, so they're not next to each other. No angles next to each other are vertical. This angle and this angle are vertical to one another. And on the sides, here and here. We don't have to color fancy, so if you're using highlighters, just do it really quick. All right, so we said, and I had another student use the word opposite each other yesterday, wasn't it, Kenny? I think you brought up opposite of each other. Angles opposite each other was another nice way to put it. So if they match, that's the ones they are, okay? I think you can tell. If you don't have colors and you want to do something like this, this would work. Show an arc, single arc there and there. Those two are congruent. And then going this way, those are congruent. Anybody can put that on their picture because they are congruent angles. Okay, I need to jump over to the right side. I went too far, or was that the right side? I'm confused with myself. Yes, that was the right side. Okay, I'm going to do these two together at the same time because they're kind of connected in a sense that you have to get them straight, which one's which. Complementary angles. These are two angles. What do they do? Yeah, they add to 90. All right, they add up to 90 degrees. They are also adjacent in this picture, but they don't have to be. Okay, so complementary angles add to equal 90 degrees. So if you had like expressions on them, you would add it up and set it equal to 90. Now, I said something yesterday about how to remember difference between complementary versus supplementary. Bless you. Complementary angles add up to 90, supplementary add up to 180. And I also mentioned that you want to think, well, if you can't get it straight or you're trying to remember, C, complementary, the C comes before S in the alphabet, 90 comes before 180 in the numbers, okay? Sooner in the alphabet, 90, later in the alphabet, 180. The ones below here are supplementary angles. When you take this angle plus this angle, it adds up to 180, yes. Add to equal 180. Okay, now, if they are making a straight line, if they're adjacent and complementary, then they're also a linear pair. Thank you. Okay, not from, never mind. I didn't think you'd be coming back to school this late if you were the doctor. So, all right, jumping over to on the right side of your ISN, here are our complementary angles. COM, P, LE, M, ENTARY. Wow, that's a mouthful. Complementary. We're going to be able to abbreviate that COMP. Okay? A lot of times I will abbreviate complementary to COMP. And again, it's angles that add to 90. They can be adjacent or non-adjacent. So the ones right here are adjacent. So these are adjacent and complementary. And I just know a lot of you like the colors. So it's that angle plus this angle, and they will add up to 90. Oh, didn't mean to color over the lines there. Okay, and then these two up here, if one of them was 60 degrees and one of them was 30 degrees, because they add up to 90, these are non-adjacent. I forgot a letter in that word. It says something doesn't look right there. I'll write it over again. Non-adjacent and complementary. They do not have to be connected. We want me to wait a second? Good? Okay. The next line is about supplementary angles. S-U-P-P-L-E-M-E-N-T-A-R-Y. We're going to use S-U-P-P for abbreviation for supplementary. I'm sure you could appreciate that. Now, if they're adjacent supplementary angles, then they're called a linear pair. And these are angles that make 180 degrees. Or, sorry, I didn't mean to write 180 there. It should say line. They make a line. I wanted to talk to you about where that comes from for a second. After I highlight these. Oh, what is that? Do not know. I'll have to try it sometime. Okay, so this angle plus this angle make a line. Does this look shape that I made look like anything that some of you grabbed when you came in? It sure does. Looks like a protractor, doesn't it? Okay, I want to talk to you about why. You don't have to write this down or anything. I just want to show you something. Well, get bigger. Oh, well, don't get any more big. That's too little. I don't like that circle. Second. I bet a lot of you know how many degrees are in this. What does that mean? What does that mean? Goes all the way around. From where? Okay, so basically, if you take this and you go like this all the way around, if you go around one time, that is 360 degrees. What if you went only halfway? Because 360 divided by 2 is 180. What's this? That's why a straight line is 180. It's just like a diameter, okay? So if you didn't think about that, I thought maybe more of you will help you remember how many degrees are in a straight line based on that. Then what did I do here? I cut it in, that one in half. There's your right angle. So later we'll talk a lot about circles and stuff to see if it's a right angle that's a quarter of a circle. I don't know why that segment did that. Anyway, I love these tools. They're kind of fun. But anyway, these are 4 pieces. Maybe this is a pizza. But anyway. Okay, maybe you'll have some tonight. Oh, no, it's not. It's not Friday yet. We have Friday night pizza night. But then now I learned how to make them. And now they want fresh pizza now. You know how much work that is? Making dough on Friday night and cooking pizzas on the wood grill? Oh my God. All right, let's say that's literally what I've been doing the last 4 Friday nights. And I think this Friday I'm taking off. Okay, if this was 140 degrees, this one is 40 degrees. And that would make these two would be non-adjacent and supplementary, S-U-P-P. And the ones up here are a linear pair, Okay, and they are adjacent and supplementary. Let's abbreviate adjacent even to ADJ. That one didn't want to go away. Okay, I think we have one thing left, and that is perpendicular lines. Perpendicular lines, really, there's not a whole lot to say about this, but the upside down capital T is the symbol for perpendicular. And if you see that little box on there, that means it's a right angle. You need to know these words. If you don't know the vocab in this class, it is a disaster. Because you won't know what you're being asked to do. If I say draw two perpendicular lines and you don't know what perpendicular means, how can you do it? You can't. Okay, so what's the point about perpendicular lines is, if you have two lines that are perpendicular, and you can have segments that are perpendicular and rays that are perpendicular as well, but if you have two lines that are perpendicular, how many angles are there that are right in the picture? How many? 4, yeah, because that one is, this one still would be as well, this one would be, and then we're back to that kind of slice of that circle that I just made. These are just the 4 pieces, okay, 90 a piece. 360 divided by 4 is 90. Now, way over to the far right. Oh, there it goes. This is perpendicular. Our symbol for perpendicular we will often use to abbreviate the word. The right angle symbol over here represents that these are perpendicular lines, and these are just, this is notation for all of that. These are all 90. Okay, now that we have these vocab words in our ISN to refer to, I want you to try doing the problems on the worksheet. And I'm going to go back also to 1.5 angle measure relationships, which was the first day that we did it yesterday. And I'm going to go to where we were yesterday, and where I had asked you to actually continue working on it and see if you guys have questions. We didn't do 17, but we did do 18. Do we want to look at 17? Well, what do we know now? If that's a right angle, then this is a right angle. So what are these going to add up to? Yep, exactly one of the things we went over today. So this angle plus this angle add up to 90. So we're just going to add those expressions. So we got 2y plus 5 plus 4y minus 5 equals 90. I hear a lot of people looking for their stuff. All right, this one is the 1.5 angle relationships packet. And we were at 17. We are looking at one more section left before we have another concept quiz on 1.4, probably 1.3, 1.4, 1.5, and 1.6. All right, combine your like terms and you get 6y. And when you do 5 minus 5, you get nothing. So it's 6y equals 90. This is a pretty quick algebraic one. Divide by 6. And you get y is 15. It then says, what's the measure of angle RPT? You need to know how to read this. That M means measure, angle, RPT. You got to go find RPT. It's right here. And you go 4 times 15 minus 5. You plug in the value that you got for y. So that's 60 minus 5, which is 55. And TPW, 2 times the 15 plus 5 is 35. Does someone know a particular question that they would like me to go over in that packet? 19? Bless you. Good idea. Very commonly missed problem. I'm going to draw a picture. Two angles, it says form a linear pair. So what do I need to start with is a line. But that's not two angles, that's one straight angle. Right, Kylie? Do you mind? Thanks. We need two angles here. So what could I do to draw two angles? And I don't know that it goes straight up because nobody said they're equal. So just a slanted one somehow. All right. Now I got one that's big, that's obtuse, one that's cute. As two angles form a linear pair. The measure of one angle is 4 times the measure of the other. Whenever you have a question like this, you didn't get given any numbers. You must pick an x, something to be x. Okay? You have to pick something to be x. If one is 4 times the other, if one of them is x, then the other would be 4x. Okay, now, where do you think I should put x, and where do you think I should put 4x to make this kind of make sense? Okay, good. That makes sense to me. The smaller one on the smaller angle. And then what do they add up to? 180, because they are a linear pair. And then you guys solve it. I'm done. Someone have another one they'd like me to look at with you? $24. Okay. Is that your phone? Your hand, or is that calculator? Shoe? Oh no. It belongs on your foot. Okay. Ralph has a slice of pizza using straight line cuts through the center of the pizza. Oh, I could do that circle thing again. We got a circle. All right. And then it says that Ralph cuts some straight lines, but he didn't do it the same size. They weren't all the same size, but he noticed that two adjacent sides are complementary. Complementary means they add up to 90. We need to know the word. And I just put my center in the wrong place because that wasn't cooperating. So you notice two of them made a right angle. One's different than the other. Then he said one is 2x and one is 3x. Now, how the heck Ralph found out one's 2x, and I know this is kind of contrived because at home I'm not thinking you cut the pizza and said one of them's 2x and one of them's 3x, but you know. Anyway, we'll go with it. What do they add up to? I'm sorry, I think some of these are very unrealistic, but this one in particular. They add up to 90. All right, you got to just know these key words. So how do you know what to do with the problem? You find that you've got complementary angles and one of them's 2x and one of them's 3x, then you can just do the problem. That's all you really needed out of the whole thing about Ralph and his pizza. Now we're going to find out how big they are. So first you figure out what x is, and then you have to plug it back in. So the answer is not just 18. It's actually two different answers. You want each angle. You got to do 2 times 18 and 3 times 18 to get the answers. 36 and 54. Okay, now anybody who's looked over these problems already have another one they'd like to check the answer on, or see if you need to know how to do it, you may ask. 22? Okay, this kind of question is going to be The most basic question I can possibly ask, and I'm not criticizing for you asking. Please don't take it that way, okay? So find what we need here to know. What's the key word in the sentence that you need to find? Yes. That is the same as complementary. So if they are complements or supplements, then you know right away they add up to a certain amount. Okay, so if one angle is 57, all you have to do is subtract. If you know one of them, you subtract from 90. If it's complementary, if it's supplementary, you subtract the angle that you have from 180 and you'll get the other one. Okay? So what I'm trying to say is the measure of angle, you don't have to write all this out to do the problem. They add up to 90. You put in 57 and you subtract to get the measure of angle 10. So I'm saying you don't need to write all this equation. You just need to go 90 minus 57 and say measure of angle 10 is 33. No, 33. Okay, so how do you figure out this next one? You go like this. You say measure of angle 7 is 180 minus 41, and you get the answer. Okay? That kind of question you must be able to do on the next quiz. Any of these are game. Anything that's in a homework assignment is game for a quiz. Something else? So we want to go back. This was from which section? This is from 1.5. Does anybody want to look at 1.4? We have something on 1.4? Okay. These words, opposite rays, bisects, etc. These are the key things in 1.4. Concepts you'll need. This is the 1.4 packet, or we can look at what you got on anything. Tell me what it is you want me to look at. Oh, on the 1.5? On 1.4, okay. Did you tell me a number? You didn't tell me a number. 25, Takasha said. Okay, so let's go there. Oh, so what you would need is the protractor. Okay, so I'm going to grab one like the one you can borrow from me. To make an angle, you must start with a ray. So all you want is a ray on your paper. Just make one with a straight edge. Grab the protractor. Put this part right here where the lines cross right there. Put it on your ray. Like that. You want it to point on the ray. All right, now where would the 45 be if I'm looking for reading from this side? So, Takasha, if I'm reading from the right side, I read the inside numbers. If you have your arrow pointing this way, you're going to read the outside numbers. All you do is you go out here and you make a mark at 45. Okay, then grab your straight edge. I made a mark right there at 45. Okay, I went 10, 20, 30, 40, and halfway. Then I'm going to take the protractor and I'm going to just use it for a straight edge. Wait, I want to rotate it, so I'm going to go just connect it like that to that mark. And then I'm going to connect from the end point here through there. And if you use your straight edge, you guys will have a straighter line than I just did. Make arrow on the ends so you can see them. And then it said to label it angle. So this is 45 degrees. And it wants us to call it angle PQR. So where's the Q have to go? At the vertex. Good wording. So the Q goes here at the corner, or vertex, and P and R go on the rays. One has to be on one ray, one must be on the other ray. And I'm glad you asked me about how to measure an angle, how to draw an angle. Do you want to do another one? That's it. Yeah. You make a 45. 26? Sure. There isn't a 20. Where is it? Oh. Is it in here? I don't know what that is. I have no idea what that is. Well, what is 26 say? Oh, here it is. I guess this said B, so you said this is 26? Okay, I just don't have it labeled right. There we go. All right, so we just did the 45-degree one. We need to start with the ray. So I don't care which way you wanted to go, but I'm just going to do this. Go this way to the right. Since I did the last one that way. I take a protractor. I put this part of it right there at the vertex that I just made. Oh, don't want that. I slide it like this and put it here. Okay, then I'm going to measure. You see how this is pointing to the right? There's 0 right here. I think I'm a little crooked. I need to slide this down just a tiny bit. There we go. So I'm pointing it to 0. Oh, didn't want to do that. Okay. Don't know what that is or why that came up. Let me get rid of it. All right, then I'm going to find 120. So I'm reading the inside because the arrow's pointing to the right. 0, 10, 20, and I come all the way around till I find 120. And then I make a mark out here. You see that 60 and 120 are there? You got to know which one of those to read. Since I'm doing a 120 and I came all the way around from 0 to here, you want to make a mark where the 60 and the 120 are. I have correctly done it because I went all the way like this. Okay. Now, I'm going to grab my protractor and use it as a straight edge. To connect the vertex here to that mark. I can get it to do what I want. Not quite right. I just connect the vertex through there. Ew. That's 120 degrees. And the label STV. So how do I label it? Tell me what to do. You asked me. Where do you put the STV? Okay, S up here. All right. Okay. Good. Yes, you like. I did that one, or maybe not. Oh. Okay. So I need to discuss, if we're asking 22, what the words mean. All right, it says he wants to cut it in half. He has a slice of cake and he wants to cut it in half, bisecting the 46-degree angle. What does bisect mean? That's what you need to know. Yes, it does. Cut in half. So how big is the angle that you're going to get if you cut that in half? Yep, that's the answer. So here's what it implied. He has a piece of cake or pie, and he wants to cut it in half. So you don't have to draw this to do the problem, but that angle right there that I'm whacking in half was 46 degrees. So each of these would be 23. I hope that makes sense. Oh, Donald Trump. I don't want to see him. Cadence. Can I just do them all? Sure. Make a sketch showing line L bisects segment XY. Okay. This, we have to know this means segment. So I'm going to make a segment. Call it XY. And I have a line that's cutting it in half. That's what bisect means. Cuts in half. All right, so I'm going to find the middle of this and say this figure, this is going to equal this. And I'm going to make a line that, oopsie, goes through there and call it line L. It doesn't have to be at a right angle or any special angle. It just has to hit the middle. Cuts it into two equal parts. Now, the congruent segments, and that's where the meeting is at M. So they'd be segment XM is congruent to segment MY. Those little flashes mean congruent. Okay, now the paper you're going to be turning in, you got off the cart today. Do we have any questions on that right now? On the new worksheet, number 14. Okay, yeah, this is a good one. This is number 14 on today's worksheet. We got quite a bit of time. It's not time to go, so. If someone wanted to tell me how to do this one? Find your keywords. So I got two angles that are complementary. So I don't know which one's bigger. And you said the measure of one angle is 21 more than twice the other. One of them is X, so say that again. Perfect. 21 more means to add 21, and twice it means to double it, 2 times it. Now find the measures of the angles. So these angles add up to 90. So 2x plus 21 plus x is 90. Now you can find them. That help? So anytime you do not get given numbers, you have to use x for one and then write the other in terms of x. Okay. I think you guys can solve the algebra part now, right? And then plug it in. That was from today's worksheet. I'm going to have another one.